name is Mete Atamel. I am a developer advocate at Google. I'm based in London. And today I want to talk to you about what I call serverless beyond functions. Before I start my talk, I want to let you know that I tweet and blog about serverless topics around serverless functions, containers, orchestration, event-driven in a serverless way on Twitter. So feel free to follow me if you wish. And also the slides are already on speaker deck. So if you want to grab the slides afterwards, this is the link for that. And I'm going to share this link at the end of the presentation as well. So what do I mean by serverless beyond functions? When we think about serverless, usually people start thinking about AWS Lambda or Google Cloud Functions or Azure Functions. So we are thinking in terms of functions because that's when we started seeing the term serverless, and you know they started with basically AWS Lambda with functions. But actually, over the years, serverless went way beyond functions. Now we can run applications, containers, pretty much anything in a serverless way. So in this talk, I want to do a little bit of like history on serverless, like how it started, how it evolved, and where we are today. And my point of doing that is that as we go along, I want to kind of tell you what's available to you today beyond functions, but also do a little bit of history of serverless so we can see how we ended up where we are today. By the way, feel free to ask me questions. I will try to check the chat. Let me see actually if I can. Well, maybe I cannot check it right now, but feel free to like maybe on Zoom ask me questions, and then in the end maybe we'll look at the chats and see if there's any questions along the way. All right, so serverless. What do we mean by serverless? I mean, I don't have to explain serverless in a long rounded way, but just to make sure that we are all on the same page, there's basically two different ways of thinking about serverless. The first way of thinking is what I call the operational model. And this is about how you run your code in a serverless way. So when you're talking about running code in a serverless way, you usually mean that there is no infrastructure management, meaning you don't need to set up a machine, you don't need to configure the machine, you don't need to patch the machine. Of course, there's infrastructure somewhere, but that infrastructure is maintained for you, so you don't have to do it yourself. There's base level security, so the base level security is managed for you. Of course, you need to think about authentication and authorization, but you don't have to think about, for example, blocking the ports or doing like that kind of base level security. You usually take that granted in a serverless operational model. And for me, one of the most important aspects of serverless is you only pay for usage, right? I mean, back in the day, we used to have machines, we used to have virtual machines, and you would get charged per minute, per second, whatever. But it wasn't usage-based, meaning no matter who used your machine, you would still be charged for it. Whereas in serverless services, you typically get charged per user. So if no one uses your service, you usually don't get charged, and that has cost benefits for your application. Now, another way of thinking of serverless is programming model. So when you're building services, when you say a service is serverless, you usually mean it's a service. So it's not like it's not like batch processing or something like that. Usually it's a service-based kind of application that gets triggered by an event. So something triggers your function or your container. This can be HTTP, but it can also be something else like a pops-up message or a storage event or something like that. But it's event-driven usually. And usually serverless programming model assumes that your service is stateless in the sense that it doesn't have state within itself. It has state externally somewhere. And this is important because the service has to scale. And when it scales, it's much easier if the state is external rather than internal. So this is roughly what we mean by serverless. And of course, like if you look at Twitter or blogs, everyone have their own definitions. But I think in the end, like there's no precise definitions in software engineering. There's only definitions that people tend to agree in a roughly kind of way. So I think this is what I would call serverless when we think about serverless. Now, when you look at the different phases of serverless, I think there were four distinct phases that we went through, and I want to go through those phases in that order. The first phase, and I call this 0th phase, is, it's what I call serverless before it was called serverless. So, and I think we had serverless for a long time, but we just didn't call it that way. So I just want to look at that briefly so that we can capture that. Then afterwards, we started having simple functions like AWS, Lambda, Google Cloud Functions, Azure Functions that kind of started this term serverless. Then afterwards, we started having containers coming into picture and running containers in a serverless way. And we also started seeing serverless becoming more mature. So more workloads and more use cases are now being supported in a serverless way. And finally, the phase that we are in right now is the expansion and integration of serverless. So we started seeing serverless being the de facto way of running code in the cloud. And we also started seeing serverless kind of integrating with what we already have. So even though you might not have something running in a serverless way yet, there are ways to integrate that into things that can run in a serverless way. And I'll explain that once we get there. So let's go through these phases and see how we started serverless and how it evolved. Now, the 0th phase, the serverless before it was called serverless. And I don't know if anyone recognizes this logo, maybe you do, but this is Google's App Engine. And this was launched back in 2008. So 2008 is like more than 12 years ago. So 14 years ago, it's a long time ago. And the goal of App Engine was to make it easy for developers to build, manage, and scale web applications. So what you would do with App Engine is that you would just write some Python code. Initially, it was just Python, and later we added Java and other languages. And then you would just write some Python, and there was a command line tool, and you would just deploy that code to some service that's run by Google. And that was it, right? So there was no service to provision, no database to manage, because App Engine had its own data store that came with it. And there was no networking or load balancing to configure. Everything was done by default. But so if you think about it, like this was very much like serverless, right? You just write some code, deploy it, and then things just work. But we didn't call it service. We called it fully managed because it was code that was managed for you on your behalf. So I consider this kind of the beginnings of serverless, even though we didn't call it serverless. So when we look at this phase, the state at this stage is that App Engine and similar technologies like App Engine, they paved the way and the vision for serverless, right? So we didn't call them serverless, but they really started serverless, even though it took a long time till we get the term serverless. But they were very limited. They were very limited in terms of supported languages. So on App Engine, we only had Python, and then later we had kind of a Java. But for the rest of the languages, there was no support. And even with Python and Java, we supported a very limited subset of them. So in Java, for example, it was a certain version of Java, and even within that, it was kind of like the subset of. There were some APIs that you couldn't call, for example. So it wasn't great for people who wanted to do something different. So if you could use a certain language with a very limited subset of that language, it could work for you. But if you couldn't, then you were kind of left on your own. It was HTTP based. It was mainly for web applications. So if you wanted to run anything that's not HTTP, you were on your own. The ecosystem was very limited, right? We basically told people, write your code, deploy to Google Cloud or App Engine, use the App Engine data store, and everything will be great. And it was great, and many people actually used it and they liked it because it abstracted away a lot of things. But at the same time, you don't build applications in a vacuum, right? It has to work with an ecosystem. And people were worried about vendor locking rightfully, because once you have your app running an App Engine, what if App Engine goes away? If you want to use an open source project along with your App Engine, is that possible? Probably not. So even though it worked, it wasn't integrated with anything else really, and that was a big limitation. And at the time, people were running code on virtual machines, and these virtual machines, they were usually on-prem, right? So when you have people running code on-prem virtual machines, and you tell those people, forget about all of that, move your code to this new way, and just let us figure out, let us run everything in a fully managed by our own App Engine. That was a big step for a lot of companies, because people do investments, they have infrastructure, they have tools and processes around what they have, so they can't just leave everything and just go with this fully managed way in a big step. There was nothing in the middle that helped people to go step by step, right? And I actually, in my mind, cloud is an answer to that. Cloud is kind of the middle ground where it gives you a way to run VMs in the cloud, then it gives you a way to run your containers, and it gives you a way to run functions, and then gradually you go all the way to serverless where everything is managed for you. But at least there's a path to that, rather than just take this and just forget it and then run this new way. All right, so that was the time before serverless. The next phase of serverless was what I call simple functions. And the idea here is that this was started by AWS Lambda in 2014, which was followed by Google Cloud and Azure Functions in 2016. But the idea is that you have a function written in some language, and then you just that function typically gets an HTTP request and responds with HTTP response, but it could be event-driven as well. And then you just define this function and you just deploy, and then everything about the function, how the function is deployed, where it's deployed, auto scaling, networking, all that kind of stuff is done for you in an automated kind of way, right? And actually, we can look at this. Like maybe let me see if I have my console open. So if you, for example, if you look at Google Cloud, if you go to Cloud Functions, I just want to show you quickly like how easy it is to do these things. We create a function. We have 2 generations. So let's say function Java JCON. Then for the region, let's say Europe West, and then we do next, and then we choose a runtime. You see there's different runtimes: .NET 6, .NET 3.1, Go, Java 17, Java 11, Node.js, so on and so forth. So let's say we are happy with Java 17. It gives us some basic HTTP function, and we hit deploy, and that's it. Like, now the function is being deployed. It's going to be, provisioned, auto scale. You get this nice dashboard and everything. And as this is deploying, we can actually look at some other functions. So we have some functions already running. And if we can look at the function here, we can click, and it's a private function, so I won't be able to reach to it. But you see how easy it is when you can just deploy a function and get the rest just taken care of for you. But one of the biggest problems with functions like Google Cloud Functions or Lambda or Azure Functions is that you need to look at this table, and this table is probably already out of date, but it actually lists the languages, the languages that support it. So Node.js, Python, Go, and so on and so forth, and also the versions of the languages that are supported in each platform. And as you see, there's differences, right? Like maybe Java 11 is supported on Google Cloud. I think now we have 17, so I should add 17 here. Lambda has 8 and 11, and so also Azure. PHP is on Google Cloud, but on Lambda and Azure, I don't think there is PHP support. Maybe there is in some other ways, but not natively when I looked at it. But the point of this table is that you have to pay attention to your application. You have to pay attention to your language. You have to pay attention to the version of your language, and make sure that the runtime that's given to you actually supports your language and version that you're using. So it's still something that you need to think about. And when you look at the function, it's usually triggered by HTTP. So it's a HTTP triggered function. And on Google Cloud, in the first generation of Cloud Functions, you had a handful of other triggers. So you had like cloud storage trigger, where the user drops a file and that creates an event and that your function can get, or maybe you have a pops up topic and then someone sends a message to the topic and then that message can end up in your function. So there were a few other triggers, but they were very limited. Like there was only a handful of things. So main HTTP driven and some kind of like storage or PubSub or Firebase triggers at this stage. And when you look at the execution model time and resources that you have in these functions, again, in Cloud Functions Generation 1, and I'm giving examples from Google Cloud because I know them in detail, but this is probably true for all functions on other cloud providers. They all went through these phases. But when you look at the first generation of Cloud Functions, they're HTTP based still, so it has to be HTTP based. Even the events that I'm talking about, they were sent by HTTP, so you couldn't do anything like non-HTTP based services or background tasks or anything like that. The request time was limited, so by default the function had to return within 1 minute, and you had maximum 9 minutes. So you had to do things pretty quickly. You can't do like batch processing for a long time, for example. And the memory and CPU you get was limited. So you had 8 gigs of memory and 2 CPU. So it was smaller functions, but you couldn't do anything big if you need more memory or CPU. And there was this problem of concurrency. In Cloud Functions Gen 1, concurrency was 1, meaning every time a request comes in, we have to create a new function to handle that request. Then another request comes in, then you have to create another function. And this led to a problem called cold start problem, meaning if your function takes a little bit of time to be created and deployed, then the user will recognize that because concurrency is 1. So every time a user makes a request, a new user makes a request, a new function is being created. That takes a little bit of time. That means latency for the user. And there was also no minimal instances. So you couldn't, for example, say, oh, I want to make sure that there's at least this many functions running at all times to handle, extra requests or something like that. There was no such thing. Because of that, people actually realized this via cold start. So that was a problem. And once you started having a lot of functions, at some point you want to be able to group them together, right? Because functions, they have this problem of one function, one path, right? So let's say you're building an API, right? In APIs, you have the base URL, and then you have like other URLs for the API. So you have multiple paths. But usually a function handles only a single path. So if you want to build an API, what you usually do is you deploy multiple functions for multiple paths, and then you use an API gateway in front to be able to build this API, basically. So the API gateway decides, given the path, which function should receive the call. And actually in AWS, API gateway was introduced very early, 2015, because that was the only way to have public functions, whereas Google and Azure, they have their own API gateways or API management, whatever it's called. And all they were trying to do is basically give you a way to group your functions into APIs. So we had that pretty early on in all cloud providers. All right, so if you look at this phase of serverless, so we had functions, but they were limited in languages and limited in the versions of the languages. We had some triggers, mainly HTTP driven, but they were really limited. We had some CPU and memory, but they were really limited, so you couldn't run anything big or long running on functions. We had this cold start problem because we didn't have concurrency, and we also didn't have minimal instances. And I didn't mention this, but also there wasn't much support for local development. So for you to be able to run your functions and test your functions, really you have to deploy to the cloud and see that it works in the cloud. So there was not much local development support as well at this stage. And once you have multiple functions, there was a way to group them together using an API gateway. But that was very primitive in the sense that you couldn't do anything more complicated than just URL paths. There was no orchestration. that I will show later. So there was some grouping, but not much beyond just simple API gateway. All right, so now in the next phase of serverless, we started seeing containers coming into the picture, and we also started seeing serverless becoming more mature. And let's look at containers first. You know, one of the things about serverless functions is that, as I mentioned, there's a runtime given to you. So if that runtime works for you, for the language and the version, great. But if it doesn't, then you were kind of left on your own. You had to figure it out. Now, so we had this world where you had this serverless world with the runtime, and that gave you a lot of velocity to iterate and run fast, because all of the things that the serverless framework is taking care, it's not your problem anymore. So that allows you to iterate fast. But as soon as you can't be here because of the runtime, then you had to fall back to containers and run your code in a container. That gave you the flexibility, because in containers, you pretty much define your own runtime. You can choose any language you want, you can choose any library you want, and you define your environment based on your context in a container. So that gives you the flexibility that you need, but then all of a sudden there's no easy way to run the container. You had to think about things like Kubernetes, and Kubernetes, as much as I love it, it's a lot of complexity, right? I mean, you had to worry about clusters, how to create the cluster, then you have to take your container, run in a pod. Then in Kubernetes, there's all these terms like pods and services and load balancers, this and that. So Kubernetes helps, but it also introduces a lot of complexity to your architecture and a lot of new terminology that you need to learn about and make sure that you actually understand. So we lived in this parallel world for a while. But thankfully, we started seeing technologies like Cloud Run on Google Cloud. On AWS, there's App Runner, and even AWS Lambda now, I think it runs containers. Then there's on Azure, there's container instances. So all of these services, even though they are very different from each other, they all try to do similar things in the sense that they all try to run containers as if they're serverless functions. So they try to run containers serverlessly. So we started this functions world and container world coming together in serverless. And actually Cloud Run, it's based on an open source project called Knative. Knative is a project that tries to make it easy to run containers in a serverless way on Kubernetes. And then Cloud Run implements that Knative spec for Knative serving. So that way, if you're running a container on Google Cloud, you can just say, okay, here's my container, just run it, and it will just do all the work. So you don't even have to worry about a cluster or anything like that. And then we have this thing called Cloud Run on GKE or Anthos. That's kind of the middle ground between fully managed Cloud Run and Knative. So it allows you to run Cloud Run on a GKE, Google Kubernetes Engine cluster. And actually, let me show you this quickly. So if we again go to, let's say we go, let me make this all the video. So let's go to Google Cloud Console again. Then I go to Cloud Run. And I have some services, but let's just create a new one. And you can choose any container image you want. So usually you have your container image ready already and push to Google Cloud. But here I'm just going to use a sample hello container. So I'm just pointing to that sample container. I gave this a name, service name, hello. Let's call this hello JCON. Then let's deploy this to, let's keep it for the US. And then there's some auto scaling things that you can set, but let's also make sure this is a public container and hit create. And now we are creating a Cloud Run service that's using this hello container that we already have in Google Cloud, but you can deploy any container really. And then within a few seconds, this will be ready and it will be running with a public URL, and it's already deployed. You see that it's getting all the traffic. And if we click here, we see that the code is already running. So you see how easy it is now to deploy containers. No Kubernetes, no cluster, no VMs, nothing. Just point to your container, deploy, and then the rest is done. And if you look at the YAML, you can actually see that it's a Knative service. So it's based on Knative open source, but we are running on Google Cloud, and we can see logs and things. So just a quick way of just showing you how that works. And this container that we run, of course, you can run anything within a container, but for Knative and Cloud Run, the container has to adhere to a contract. So it has to listen on 000, and it has to listen on a port environment variable. It has to be an HTTP server that starts within 4 minutes. It has to respond within 5 minutes by default. So you still, well, and you can change this to 60 minutes, meaning when a request comes in, your container has to respond back within 60 minutes, within 1 hour. So that means you can now do a little bit of batch processing that lasts up to 1 hour, but it has to be done within an hour. It's still stateless in the sense that the container can have some in-memory file system, but that file system is in memory, meaning when the container scales down, it will be gone. So you want to still persist the state outside your container. You can only do computation within the requests. You have some resources like CPU and memory. Now we can get up to 4 CPU, 16 gigs of memory. Concurrency is now more than 180, and I'm going to talk more about this. And you can have up to 100 containers by default, but you can change this to 1 to 1,000 containers by default. And you also have the ability to listen on multiple paths. Because this is a container that runs an HTTP server, you can actually have a single container listening for multiple paths. So you don't need an API gateway just to be able to support an API. And this kind of simplifies things a little bit. So even though you can run any container you want, the container has to adhere these kind of rules, and it has to be HTTP based. The concurrency now in Cloud Run and also Cloud Functions generation 2 is more than 1. It's 80 by default, which means 80 concurrent requests can be handled in a single container or function, up to 1,000. You can change this. And with this, cold start becomes less of an issue because, when a request comes in, you don't have to create a function or container every single time. It's more likely that there's already a container running. And also, there's this minimal instances setting that you can set in Cloud Run, where you can say, I want to set 5 instances by default, and the Cloud Run there will be 5 containers running at all times, no matter what, whether you have request or not. So with that, cold start becomes less of an issue. It can still happen, but much less frequently than before. And at this stage, we started seeing some improvements in local development. So since it's containers, you can run them locally within Docker and debug them locally. You don't have to push to the cloud to see that. There's build packs to take your code and convert to containers. That makes things easy. There's functions framework on Google that gives you a way to run Google Cloud Functions locally, so that way you can test them and run them locally. There's emulators for PubSub and data store and other services that helps for functional, well, not functional, but like for testing, basically, that where you want to emulate certain parts of your infrastructure. And then I think on AWS, there's certain projects like Local Stack, for example, that lets you create a stack locally. So that, again, you can do testing and debugging and stuff like that. And then the other improvements, I won't get into these too much, but basically you get more processing time. You get more memory and CPU. You have always on CPU for background processing. You have build packs for source-based deployments. And I guess one thing to point out is richer protocols. So at this stage, Cloud Run supports WebSockets. It supports gRPC, which is an open source protocol for rich connectivity between clients and servers, and server-sent events as well. So we started seeing some protocols beyond just simple HTTP request and response. It allows us to do more real-time connectivity between clients and servers. And then we also started seeing some basic orchestration around these services. So if you want to, for example, call a function or a container on a certain schedule, you can use Cloud Scheduler to do that in a serverless way. or if you want to do a task-based use case, for example, a user does something, you create a task, push to a queue, and then you can have that task pushed to a container or function. You can do that with cloud tasks. And again, on AWS, this is called CloudWatch. Azure, it's called Scheduler. And then the cloud task is probably SQS or Service Bus on Azure. So no matter where you are, you have these like basic orchestration tools around your services and containers. All right, so at the end of this second state of serverless, now with containers, we have any language that we will want to use, you are able to use it with any version, as long as it adheres to the contract that I mentioned earlier. The triggers are still limited in the sense that everything is HTTP driven for the most part. The execution model, the time and the resources that you get in your container is improved, but it's still limited in the sense that there are some limits you need to think about. The cold start is not much of an issue anymore because we have more concurrency and we have this minimal instances setting that we can use to have some instances ready to go. We have improvements to local development with emulators and other tools that I talked about. And we started also seeing some basic orchestration around functions and containers, even though they're very basic. So things are improving at this stage. And now in the last stage of serverless, I think what we are seeing is basically serverless expanding and integrating with what we already have. So let's take a look at this last phase that we're in right now. So when you have a few services running, at some point you need to figure out, okay, how do I kind of get these services communicate, and how do I get them kind of cooperate for a common kind of goal? One way is that I don't show here is you can have services calling each other directly. So service A can call service B can call service C. It's not a good idea in the sense that you're creating dependencies between your services, and it makes things harder to update and harder to maintain. Now, there are other ways of getting your services to cooperate. One is called choreography. It's basically event-driven kind of architecture. And this picture is a little bit misleading in the sense that it shows service A sending an event directly to service B. It doesn't really happen that way. You usually have a service bus in the middle, and then the service A will send the event to the bus, and then the service bus will figure out, okay, who is interested in this event, then it will take it and send it to service B, so on and so forth. But in this model, you have loosely coupled architecture where services, they don't know about each other, they just kind of communicate indirectly with events. So it's good for that. But at the same time, event-driven systems, they can be difficult to monitor because when something doesn't work, it's not immediately obvious where things failed because there's some event maybe wasn't processed, but you can't see that right away. So it might be a little bit more difficult as your architecture expands. Now, another way of getting your services cooperate is that you can use an external orchestrator. And in this approach, you define how service should be called, and then your orchestrator can call the services in that order. So here we have something called workflows on Google Cloud. Workflows can say, okay, I'll call service A, get the result, then I'll pass that result to service B, and then get the result, and so on and so forth. So in this case, the orchestrator is the one making these calls for you. So now when we look at choreography, event-driven, there's services like EventArc on Google Cloud for high-level eventing. So EventArc allows you to create a trigger that connects different sources to different consumers. And we also have PubSub for lower level connectivity, where you create a topic, and then the subscribers and producers, they send messages to the topic, and they receive messages from that topic. Again, on AWS, there's SQS, SNS, EventBridge. Azure, there's EventBridge. So there's a lot of options here. So there's a lot of services basically that can help with this kind of event-driven architecture. And what this means for your services is that now all of a sudden, instead of having just a few triggers, you can have a lot of different services that you can receive events from and send it to your functions or containers or any other services really. So all of a sudden your event space and the event sources, they just increase from a handful to basically whatever event arc supports, which is hundreds, if not more. And then in terms of orchestration, Google Cloud has something called workflows that lets you orchestrate services. So if you have this kind of flow, for example, where you talk to a database, get the result, check the inventory, and call a third-party API, so on and so forth, you can take this architecture and you can actually convert into an orchestration and let workflow kind of call it for you and make sure that this flowchart happens in the order that you define. Again, on AWS, there's step functions, and on Azure, you have drawable functions and logic apps that do this kind of stuff. And in terms of workflows, workflows allows you to orchestrate basically your code running in Google Cloud. It also allows you to orchestrate Google APIs and even external APIs, whatever you want to include in your orchestration. And maybe I show you a quick example of this as well. So if you go back to Google Cloud, if you look at workflows, let's say I want to chain a few services. By chaining, I mean I have 3 services, and I want to service A call service B call service C, so on and so forth, but I want the orchestrator to do this for me. So how you set this up in workflows is that first you deploy your services. So in this case, I'm using Cloud Function to deploy them. So I have this first service called random gen. It's a Python function that creates a random number. So it just creates a random number. So I deploy that function. Then I have another function called multiply that takes a number and multiplies it with another number, I think. You pass in one number and then it multiplies it with what it has. So it's a multiplication function. Then I have this another function. It's an external function in Math.js. In Math.js, you can pass in an expression like this, like a log function, for example, and pass a number, and it will return the result to you. So that's an external function that I want to include in my orchestration. And finally, I deploy a Cloud Run function, which is a container that does floor, meaning you pass in an input like 6.86, and it will just take the floor of that number, which is 6, right? So when you look at this, you have 2 functions, cloud functions, one external function and one container that you want to orchestrate. So to create this orchestration, you create a workflow.yaml file. And in here, you define what your orchestration should do. So you see, we define our steps. So the first step is to call this random gen function, and workflows will call this, and it will get the result and save the result into this variable. Then it will call the multiply function. Now this time actually proposed, and the input will be the result from the previous step, and then we'll capture the result in multiply result function. The third will be a call to the external API to Math.js and capture the result here. And then finally, the last call will be to the floor function. That's a call to the Cloud Run service that's authenticated. So we're passing an authentication token, and the input will be from the previous step. And the end result is just the result from the last function. So you see, this is how you define your orchestration. And I already have it here. So I'll just show service chaining. I will click here, look at the source, and you see that we have the description here. We have a visualization here, so I can see what's happening. And if I want to execute, I just execute from here. I'll just call, and then now this will do all the calls. So you can see we're calling the multiply function, floor function, and then finally it will be return result. The result is just a number that we got, but you see that all the functions have been called. So workflows allows you to do this kind of stuff, which is really cool and easy way of kind of connecting services together. And once you have the orchestration, you can also do cool things like combining event-driven architectures with orchestrated architectures. So I have this example. I'm not going to show the details here, But just to mention this here, it's an image processing pipeline where a user saves an image to a storage bucket, and that triggers an event via event arc that goes to workflows, orchestration, and the workflows will process this image using some functions. So there's a filter function to filter the function, whether it's a safe image or not. There's a labeler function that extracts the labels from the image using machine learning. There's a resizer that resizes the image, and there's watermarker that takes the resized image and it takes the labels and creates a new image with the resized image and labels on top and saves to the output bucket. Now, in this case, we are combining orchestration and choreography. So here we have the orchestration because these functions, they have to be called in this order, and the input of one is the output of one is the input to the other, and so on and so forth. So that's a perfect example of orchestration. But the whole orchestration gets triggered by an event. So in that sense, it's event-driven orchestration. So I see this quite often, like this kind of architecture, and it's really useful to orchestrate what you need, but also make it loosely coupled with everything else in your architecture using events. Another thing that we started seeing in this phase is combining serverless with serverful. And what I mean by this is that, let's say you have a long-running task that needs to run, a day or a week or maybe a month, a year, right? Right now, there's no easy way to run that in a serverless function or serverless container because there's all these limitations on how long a serverless service can run. But what you can do is that you can create a virtual machine and set what you need on the virtual machine, the CPU and the memory and everything, and then use orchestration. You use workflows to automate that. So the orchestrator will provision the VM. It will run the code, in this case, a container on the VM with no time limitations. And then it will kickstart the process, whatever you need to calculate, and then it will get the result back. And once it has the result, it will delete the VM. So I show how to set this up in this example. And in here, the key point is that you have something that you need to run in a server, in a VM, because of the limitations of serverless, but you can make that serverless by orchestrating it using services like workflows. And this pattern is very useful to kind of make things easier, even if you cannot run them in a serverless way end to end. And then we also started seeing this, what I called non-HTTP run to completion containers. Sometimes you just want to run some code, do some batch processing, and then finish, right? It doesn't have to be HTTP driven. It just needs to run, do something, and then finish. There's actual services like now called, for example, Cloud Run Jobs that enables you to do that. It enables you to run a container and run it until it completes without much time limitations. So I have a couple of examples of how you can do that as well. All right, I think I'm almost out of time. So to wrap it up, the state of serverless as of now is that you can pretty much use any language and version of the language you want, whether this is in the function runtime, or if that's not enough, you can create your container and use your language in the container. So that languages is not an issue anymore. We have a lot of rich triggers. So you have event arc and event grid and event bridge and things like that, that basically allows you to connect any service that you have to any event source, not any, but to a lot of event sources. So you have a lot of rich triggers. We have much improved execution model times and resources. So we can run things longer. We can have more CPU. And in the worst case, we can combine service with serverless to run whatever we want, basically in an easier way. Cold start is not an issue anymore because of concurrency and min instances. Local development is not an issue anymore because we have containers and other local stack and other projects that help us to do the local development. And we have a lot of rich orchestration now with projects like workflows and logic apps and everything that allows you to combine a lot of serverless things together into this rich orchestration and do even more. So I think we are in a good shape, and we didn't even talk about other things. I mean, most of the stuff that I talked about They're about how do you run your code in a serverless way. But once you have that, you need to think about your data. So how do you have your data and have the data in a serverless way? So there's NoSQL databases like Firestore, DynamoDB. There's SQL databases that are not truly serverless in the sense that you still need to think about them as units, and you need to kind of think about the capacity in Spanner, for example, a little bit. So it's not truly serverless, but they get close enough that it's worth to think about them. And there's data warehouse solutions like BigQuery, caching with memory store, which is based on Redis, but it's managed. And even when you want to do things like sending an email or making a call, there are services like SendGrid and Twilio. They're services, but they help you to kind of make those with just a call, an API call, rather than trying to do that yourself by running a VM or something like that. So my point of this slide is that once you figure out how to run your code in a serverless way, also try to see what else you can run in a serverless way that's not your code, because there are options there. And once you do, it would be a shame to have your code running serverlessly, but the backend is a DB that you have to maintain and update on, stuff like that. It will be good to choose something there as well that's kind of a little bit closer to serverless. So the whole point of this talk is that now I think serverless is now the default way of running code in the cloud. So if you're working on a new project and you want to use a service, see if you can do that in a serverless way. And if not, see if you can use something in the serverless world that can help you with servers, so that should be the default way of thinking. There should be serverless should be the default, but if it's not, at least there should be a way to help you with your service. Okay, I think this is all I have. So thanks very much for listening. This is my speaker deck link. So if you like the slides, feel free to get it from there. And this is my Twitter. If you have any questions, even after today, feel free to reach out to me. And I think I will stop sharing now and see if there are any questions in the chat. All right. So yeah, I see some questions. I think I have time. Yeah, I have 2 minutes, so I'll try to be quick. So someone said API gateway versus Apigee. Well, Apigee, it used to be a separate company that had this very enterprise level API gateway and more. So I would say Apigee is much more than API gateway. It includes API gateway, but it's more than that. And I think that's what I would say on that. Another question on Cloud Run: if a container starts with downsized to 0, how long it will keep running by default, doing nothing? Well, if your Cloud Run is 0, and well, I guess you mean if your Cloud Run is 1, meaning you have 1 container running, it will be like 5 to 10 minutes, I think, something like that, and then it will be scaled down to 0. It's not always deterministic, so it's not always like on a timer. It depends on the infrastructure and the demand and all that kind of stuff, but within a few minutes it will scale down. Yeah, so I would say like 5 minutes or something like that. Another question: in workflow for internal service, can we use something internal to reduce network overhead? Yeah, I mean, in workflow you can call your internal services. Yes, that you can do totally with no problems. Yeah, it doesn't have to go to the public internet to call your services. So if you have internal services and you just want to orchestrate those, you can do that. In workflow, how does fallback work? Any services down and not available? Yeah, that's a good question. So in workflow, when you call a service, if it responds with an HTTP code that's like a failure code, then you can wrap that call into a try retry block. So there's in workflow definition, you can just say try, call this service, and then retry using this policy. So you can retry a few times, and at some point, if the retry fails, let's say 3 times, then it will basically throw an error saying, the orchestration failed. Any thoughts on the future of serverless? Yeah, I think the future is basically, I mean, as I said, it's the default way of running things serverless, and it will be. So I'm expecting more things to run in a serverless way, to the point that we don't have to worry about kind of provisioning things, running things on our own. Instead, we just say, run this code and save this data, and then everything is automatically provisioned. I mean, that's the world that I want to see, at least. All right, and then the last one, if there was a big shift to serverless, would this not be a problem for cloud providers? As far as I know, serverless also comes with consumption-based. It means if you don't use a service, you ain't going to pay for it, right? So there would be much more infrastructure having to be provided, but not really used. I mean, the good thing about serverless is exactly what you said, like it's the elasticity of it, right? So when there's demand, people will pay and we provision it. And when there's no demand, it will go down. Now, is this bad news for cloud providers? I don't think so, because I think, in the cloud, the whole point of cloud is to have that elasticity. And, the more people use serverless, the more people run stuff in the cloud. So I think for the cloud in general, it's good that people are running things in a serverless way. And now you're saying, like, I guess you're comparing this to like virtual machines. So if people run everything in virtual machines, then they would pay all the time, but now they don't pay all the time. It's true, they won't pay all the time for running the code, but I guess they will pay for more things, like, for example, if they now that they can run their code in an easier way, they will use more things, like maybe they will use messaging, maybe they will use orchestration, so they would pay for those. I mean, I don't know how this is going to play out in the long run. In the long run, I think it will be better for everyone, because more people will be in the cloud, more people will be using the cloud tools. So that's good for cloud providers. And then by making it more efficient for people, we'll make our customers more happy as well. So I think it will be win-win for everyone involved. And since it's cloud providers giving this elasticity, they can optimize things as well, right? So they can do much more optimizations rather than you having to do that yourself. So I think cloud providers will be okay in that sense as well. So I don't know if this answers the question, but that's my rant about how I think things will play out. Anyway, I'm out of time. Thanks again for listening, and enjoy the rest of the conference. Yeah, thanks very much.